before you start your database journey with us. So before we start, let's have a quick introduction about us. So we in QA Velocity have 14 plus year of experience in software testing and trainings. We have provided 1000 plus hours of classroom and online training so far. While providing classroom trainings, we have asked to provide the recorded session of our trainings, and this is where the idea of online video tutorial came in our mind. So now with that, let's talk about our course, for whom exactly this course is designed. If your answer is big yes for all the below questions, then this course is designed for you. So my first question is, do you have a computer machine with database installed on it? Or will you be able to install database on your computer? Wait a minute, if you are willing to install, then we'll help you in installing a setup on your computer in the very beginning of course. The second question is, are you willing to learn, understand the technique to create database tables, or how to query that database in the best and most recent fashion? And finally, you are not afraid of trying a different technique of learning database, are you? Hold a second. If you are already a SQL programmer and looking for a reference course, then this course is not for you. Now let's talk about some of the techniques we have used in designing the course, which we believe are the best and most efficient way of learning. Our first technique is visualization. We have tried to describe the course topics with a lot of graphical examples. It helps you in understand and remember the topic easily. Second is interaction. We have included practice sets at the end of each chapter. We also see interaction in a second perspective as well, where you can submit your queries related to course and will definitely revert you within 8 to 10 hours. And third and most important technique is we have tried to add and implement the end-to-end course with a real-time scenario which we see in our day-to-day life. Let's talk about database now. Don't you just hate losing your things? Whether it's your email password, your home key, or a 50% off on coupon of a Domino pizza order. There's nothing worse than losing your belongings at the very time you need it. When we talk about application, there is no better place than storing your data in a structured database. Whether it's your employee information or your personal information, you can store anything here. So concluding the introduction with the beginning of your database journey, and let's get into habit of not losing your data. For latest updates, you can visit our website www.qavelocity.com or WhatsApp us on 9560852797. Hello and welcome to the session on Introduction to Database. In this chapter, we have tried to set context with real-time scenario where how database has made a bookseller Greg's life easier. This is Greg. Greg started a bookstore. To promote his bookstore, Greg offered a 30% discount on all his books. Greg started keeping the books and customer record manually into a notebook. After end of sale, Greg asked his store manager Jeff to give him the name, interest area, and mobile number of all the customers who bought books during sale. So when Jeff went to record room and started searching the records, he was completely confused and could not decide how to start. Can you recommend Jeff a better way of organizing the data? What would you do if you were Jeff? Would database help Jeff? Exactly, this is the correct answer, and this is what the course is for. But before we suggest Greg and Jeff, we need to have a look on the record book they are managing. These are some sample pages we have taken from Greg's record book. If you see Greg and team, they are managing the records like name, author, category, and price of books, as well as the name of customer. So before getting started with database, we need to categorize the data of record book, and same categorization can help us in providing the name of our database column. So this is how we have categorized the record book data. Before we go in more details like table, rows, columns, tuples, let's have a look on bigger picture first. The database. It's a container which stores all your tables and SQL structure. In our day-to-day life, if we see, we'll be easily able to find the existence of database. Your bank detail, airline tickets, MP3 flares, so on and so forth. Knowingly or unknowingly, we are using a lot of database in our day-to-day life. So a database contains one or more tables, and table lives inside your database and organize your data into form of rows and columns. These are rows and these are columns. Combining these rows and columns make a table. So with that, let's move to our new chapter which talks about creating a database and configuring table using SQL statement. Hello and welcome to our session on the create statement. In this session, we will see how we can define data structure of a record book in a real-time database. Table of content. In this session, we will learn the following. Create a database, create a table. We will learn about the data type we are going to use in creating our tables. The describe database command which shows the database structure. And last but not the least, we will have a practice session of everything we have learned about the chapter. The first thing we need is a database that holds all our tables. For that, we need to open our database editor and execute create database statement. So the keyword we use is create database with the name of table. Please note that space is not allowed in the name of database, and as usual the complete statement ends with a semicolon. So Jeff has used same keyword to create his database. Now Jeff have a database ready with him, but it is still a blank database. We need to add tables in it. Wait a second, what happens when we have multiple database available? How would the editor know that in which database you want to create the table? For that, SQL provides use database command to actually use that particular database. So finally, we have created a database and specified the name of database in which we are going to create our tables. Let's try to create tables in the database. So to create a table in database, we need to follow below syntax. So our command is create table with the name of table and the columns with the data types as well as the size of each of the column. With each of the column, we need to define the data types we want to store. And as usual, the statement ends with a semicolon. Let's use the same syntax to create Greg's book table. His book table contains book ID, title, category, author and price columns. So the table name is books and the columns are book ID, title, category, author and price. Comma are used to separate two columns, and finally the statement ends with a semicolon. Wait a second, where is the table which we have created in bookstore database? Yeah, that's a good habit to check your work, what you have done. To see the structure and details of your table, SQL provides a command DESC which stands for describe. You just need to write DESC and the name of table. In our case, the table name is books. If you see the description, it has the column names, the type of data that column is using, if that column can have null value or if a key is defined for that particular column. And finally, that column has a default value defined for it. Don't worry about new words like keys or null right now. We'll talk about each of these in our following chapters. So finally, we have bookstore database with books table in it. So as we have seen in previous example, we have used only two of the data types, varchar and double. The question which comes in mind is, are there more data types available? And the answer is yes, there are few more data types available in database. Why should we use multiple data types? Can't we store all the data into these data types? Alright, that's an obvious question. But if we use only two data types, it would be a big challenge for us in latter phase of implementation. Let's say you have an integer data type and you stored the same data into a varchar data type. Then it would be interpreted as a string. And in future, if you would like to perform some mathematical operation on that column, it would not be possible. Let's have a look at few more data types and what do they do. First and very common data type is integer. It stores a whole number. Our second data type member is varchar, which we have used before. It stores text data and the limit of text data is 255 characters. To overcome the limitation of varchar data type, blob data type is introduced. It holds large amount of data type. Let's say you want to store an XML file in your database. Then you need to define your column as blob. Our next data type is decimal, which stores decimal values. Because if we see integer, it only stores whole number. So to store decimal values, we need to use decimal data. If you only want to store date in your column, then you can use date data type. But if you are concerned for time as well, then you need to use date time data type. So these are some data types we are going to talk about in our further chapters. Hello and welcome to this session on the insert statement. Learning objectives. In this session, we are going to cover following topics: the syntax of insert statement, different flavors of insert, and a bit of explanation about null value. Let's begin with Jeff's story. In our previous session, we have helped Jeff in setting up his bookstore database and also helped in configuring book table in it. We have the database and table ready with us. Now it's time to fill the manual record book data into book table. So let's have a look on syntax of insert statement. If you see, it starts with the keyword insert into, followed by the name of table in which we are inserting, and then the name of columns separated by comma into small bracket. So we have provided table and column name. Now it's time to assign values to these columns. For that, we have a keyword called values. So after column name, we need to add values keyword followed by values of all above mentioned columns. And these values need to put in a single quote, and as usual, the statement should be closed with a semicolon. Before we move forward, please note that the values should be in same order as per the name of column. So in the previous slide, we talked about original syntax of insert, but there are multiple ways of using insert statement. So in this chapter, we will talk about three flavors of insert. As we have discussed before, the values should be in same order as per the name of column. Well, we can also insert values by changing the order of both columns and values. Let's read the statement. You can insert table values after changing the order of column as long as matching values of each column come in same order. What does this statement means? Let's see Greg's table. If you see the order of column, it's book ID, title, category, author and price. Now let's see our statement. Have you noticed the order of columns we are inserting? It is different than the original table columns order. Perfect. You can do that. But here is the trick. The order of values should be in same order as per the order of column names. If you try to insert a string value in price column, it will give you an error because price only accepts double values. So if you are changing the order, you need to be very careful. Why should we write the name of columns again and again if these column names are fixed? Yes, exactly. You can leave out the name of column, but you need to be very sure that the values are in same order as per the order of their respective columns in table. So before doing that, it's better to have a look on our original table. Now you are ready to write the insert statement without column names. Here we go. So if you see, we have removed the entire column name from our statement and just use values keyword to insert values. Again, keep the order in your mind before using the flavor. So is there any way if we can insert values only in the column which are required? Of course, this is exactly our third flavor of insert talks about. You can absolutely leave those columns out if you do not want to insert values in those columns. This is the original table, and now let's see our syntax and match that syntax with original table. You can see we have only three columns of table: book ID, author and title, and their respective values. However, if we have a look on our original table, there are 5 columns in it. So insert command also provide you a leverage to insert only those values that you want. Wait a second, what happened to the values of those columns which we have left out in our third flavor of insert? Well, I myself don't know the exact answer of the question. Let's ask the table itself. So to see the values of table, we need to write a select statement. Select star from books. Alright, don't worry about the select. We'll cover it in. Alright, don't worry about this select. We'll cover it in our next session. So once you execute the select statement, you will get the entire data of your table. Oh, if we see, it has inserted a null values in column which we left. Now what the heck this null is? So in SQL, null is the term used to represent a missing value. Jeff have few queries. Is null equal to 0 or an empty string? No, null cannot be equal to 0 or any empty string. Can we compare two nulls? No, one null cannot be equal to other null. For example, if you have two closed boxes and you do not know what exactly in both, will you be able to compare them? Same theory can be applied to null as well. So can I restrict my column to except null? Yes, that is quite possible during table creation. Don't worry about that. We'll talk about it in later phase of our course. Hello and welcome to session on Smart Table Design, Learning Objectives. In this session, we will learn the followings. What exactly atomicity is, different keys we will use in our SQL table design, what is normalization, how one column of table has dependency upon another column, and finally we'll talk about different type of normal forms. In our initial chapters, we have helped Jeff and Craig to design their table and query the data from it. While using the database, it filled with a huge amount of data, and in latter phase, they started facing issues in retrieving their data and wishing they would have designed their table in a way that made their statement simpler. Finally, after an exercise, they made it possible. To see how other sailors are doing, Jeff made two booksellers, Mike and Billy, who were also using database to maintain their data. Jeff asked for their table structure. So if you see Mike's customer table, he has kept city and state in same column, address, and on the other hand, if you see Billy's table, he has created a new column for city. This is the exact situation which Jeff wanted to understand and see how other people are doing it. So Jeff asked Mike why he has kept both city and state in same column. And Mike answered that in most of the cases he communicates with emails, so he does not use address much. That's why he created a single column for address. Alright, now Jeff asked Mike to give the list of all customers from California from his table. And look what Mike has written. Select star from customers where address like California. Now Jeff reached to Billy's store and asked him the same question. And what Billy told him is he often queries data using state column. So for his advertisement purpose, he kept state as a separate column. So how would Billy find customers from California? And Billy has written a straightforward query. Select star from customers where state equal to California. So what do you say? Whose table is better? As per me, both tables are correct, as both tables have designed for their own purpose. So if we see the situation for both Mike and Billy, the data is atomic enough for them. So is using like is risky? No, there is nothing wrong in using like, but it is difficult for huge amount of data, and it may be a risk that you get a result that you do not need. Alright, you are not able to understand what I am trying to say. Let's take two situations. For a pizza delivery boy, he just needs the street number and complete address in a single column. So for him, this order table is atomic enough. He can just search for his orders and get his result. He just need to directly write select address from our orders where order number equal to 305, and he would get his address. But on the other hand, for a real estate agent, he might want to have separate column for house number because he want to write select property type from properties where street is 100 Main Street. So for both of the situation, the table is atomic enough for people who are using it. Alright, let's talk about the rules of atomicity. So rule 1 says a column should not have several values of same data type. Consider this table food details. What happens when you try to search item using cucumber or onion? Will you be able to search? It seems like impossible, right? So to accept rule 1, we need to create two separate tables for each ingredients. Now what we have done is we have segregated the ingredients column into ingredient 1, 2 and 3. So now as per rule 1, our table is atomic enough. Now let's talk about second rule of atomicity. Second rule says a table should not have several columns of same type of data. If we again have a look on our food details table, we have multiple columns of ingredients and all these columns are having same type of data: tomato, cucumber, onion. So currently our table is set with rule 1 but violating rule 2. So it is still not atomic yet. So let's take a final column on our table and set it to follow rule 2. To make atomic, what we have done is we have divided the table into two pieces. One for food item, another for ingredients. Now if we analyze both tables with atomicity rule, then these tables are following both rules of atomicity. Wait a second, why should I make my table atomic? Exactly, this is an obvious question which comes in our mind. So atomicity will help us in design a smart table where we can search our result easily, and that is where the concept of normalization comes in picture. Normalization. So normalization is a process of efficiently organized data in a database. What does it mean to be a normal table? So the answer is we have a set of rules we need to consider while designing the tables. Next question, why should I design a normal table? Normal table won't be duplicate data. And my answer is normal table won't have duplicate data that will reduce the size of table. And when you have less data to search in a particular table, your query would be faster. Let's talk about first normal form. A table is in first normal form if it follows these two rules. Rule 1 says each row of data must contain atomic values that we already have discussed. And rule 2 says each row of data must have an unique identifier. In later phase of chapter, we'll start calling it primary key. But before we move further, let's make our concept clear about what exactly this primary key is. So a primary key is used to uniquely identify the records in a table. So to make column primary key, we need to follow a set of rules. So our first rule says primary key cannot be null. If you set a primary key null, it cannot be unique, as other records can also be null. Primary key should be unique. It should not be duplicate. A primary key must be assigned a value while creating a table. And a primary key value cannot be changed. So we know the rules of primary key. We'll apply these rules in later phase of our. If you see both tables we have created, these both tables are following the rule number 1 of first normal form, which says table should be atomic. Now if we remember the second rule of first normal form, it says table should have a primary key. So while making the table atomic, we already have assigned a primary key to food table. If you can see, we have FID, which is a primary key, and we can search the records uniquely using FID. But on the other hand, if we see the ingredients table, it still does not have a primary key. If you try to search using FID, there are multiple records will be populating for a single key. So to mitigate this issue, we have combined two columns of a table to search the data uniquely. So it becomes a 2-column primary key. What the heck? 2-column primary key? Can I combine multiple columns to create a primary key? Don't we discuss primary key should be a single column? I believe you also have same question in your mind. Yes, we can make a unique key which combines 2 columns to identify the records, and we call it composite key. So what exactly this composite key is? So composite key is a primary key which comprises of multiple columns to identify records uniquely. So if we combine two columns of a table to search the record uniquely, we call it composite key. Consider this table. If we individually see FID or ingredient column values, they are repeating. If you can see, cucumber value, tomato are repeated. FID values F01 is repeated multiple times. So if you try to search using F01, it will give you multiple records. Same in case of ingredients. So what we can do is we can combine both FID and ingredient column to make it unique. Now both the columns combinedly able to search a record. So finally we know what is primary key and what exactly composite key is. And we already have idea of the rules of first normal form. So it's a world of relation, right? And we are talking about relational database system. So in next slide, we are going to talk about some dependency which one column have on other columns of the same table. Let's analyze the dependency of column in this table. So let's say if we change the value of book column, it will directly impact few other columns of tables like category. If I change the book name The Alchemist, it will change the category of book. Even it will change the category of authors and copyright. And once author changes, the phone number will also be changed. It means column author, category, copyright are dependent on books column. In SQL, we call it functional dependency. So by the word functionally dependent, what I mean is if you change book, category, author and copyright will automatically change. In this table, we are treating books and customers as composite key. So book and customer, both column would be known as composite key columns, and the rest of the columns would be known as non-key columns. Now if we see author column, it is dependent on one of the column of composite key, that is books, but it is not dependent on second composite key column, which is customers. Same can be applied for copyright column. So author, which is non-key column, is only dependent on one of the column of composite key, which is books. This is what partial dependency. So partial functional dependency means that a non-key column is dependent on some but not all the composite key columns of a table. Let's talk about transitive functional dependency. Consider this table. We are treating book as a primary key and rest of the columns would be known as non-key columns. Let's say if we change book, category and author would be changed, and once author is changed, phone number would automatically change, which is a fine behavior. Now let's try to see the impact of changes in a non-key column. If you change category, author may not be changed, as he would have been written a book of different category. But if we change author, phone number would automatically change. So what transitive dependency says is, if changes in a non-key column impacts another non-key column, then we are in the situation of transitive functional dependency. In our case, table is having transitive dependency because changes in a non-key column, which is author, is impacting other non-key column, which is phone number. Wait a second, why are we talking about these dependencies? What do they have to do with our normal forms? So we are talking about these dependency as these are required to make the column normal. Let's check our rule of second normal form. First rule says your table should be in first normal form. That we already know how to make first normal form. And the second rule says your table should not have any partial functional dependency. As we have discussed earlier, partial functional dependency means that a non-key column is dependent on some but not all the columns of composite key. So if we recall our table, many of the columns like author, category and copyright are partial functional dependent on books column. So the table is not in second normal form. We need to remove this dependency, and for that we have to further divide this table. So what we have done is we have removed partial functional dependency. We have divided the table into two parts and assigned a primary key in both tables. So we have created a book info and customers info table. Now the question is, we have divided the table into two parts. So how will we write queries to get the combined data? This is where a new key enters in our directory, foreign key. So if you see book ID column in customers info table, book ID is working as a foreign key in customers info. Alright, we have already covered primary and composite key. Now what the heck this foreign key is? So foreign key is a column in table that reference a primary key of another table. Foreign key can have different names than the primary key of other table. You can set the value of foreign key as null. Even primary key value cannot be null. And unlike primary key, foreign key do not have to be unique, and generally they are not. We don't keep it unique. So now we understand that foreign key let us connect two tables. But what is the use of foreign key when it is null? Can't I restrict it to be not null? Yes, of course you can restrict it. So for that, SQL provide a feature called constraints. We will talk about these constraints in a separate chapter we have. But before that, let's talk about third normal form. So if you want your table in third normal form, then your table need to be follow the below two rules. First rule says your table should be in second normal form, which we already have created. And second rule says your table should not have any transitive dependency. And transitive dependency is when a non-key column is dependent or related to another non-key column of the table. Let's see. We have courses table with us. Let's check what would happen when we do some changes in the value of non-key columns, which are instructors, courses or phone number. So if we change course name, it will neither impact instructor nor phone number, because one instructor can teach multiple courses. And if we change instructor's phone number, it will neither impact course nor instructor, because one instructor can have multiple numbers. But if we change instructor, phone number would automatically change. So instructor is a non-key column, and when we are changing the value of non-key column, it is impacting another non-key column. And we remember the rule of transitive dependency. So as per transitive dependency rule, this table is in the situation of transitive dependency. So to remove transitive dependency, we have created two separate tables for instructors and course. Now both the tables do not have any transitive dependency. So finally, we have reached the rule of third normal form. So with that, we have hopefully completed the concept behind normalization. Hello and welcome to this session on the select statement. Let's recall the bookstore scenario. Jeff finished inserting all the books, customers and order details in his database bookstore. Now he is quite happy and confident that he would be easily able to answer all the questions of Greg. So with full of confidence, he went to Greg to answer his queries. So he went to Greg and said, "Hey Greg, I have a better solution for you now. Now I can easily answer your queries, as well as we will be easily able to manage our books and customers." So Greg, in excitement, asked Jeff to show his innovation. Greg shows the table structure of the database. He has created a books, customers and order table. Greg was happy, but being a manager of store, he wanted to test Jeff database with some real-time scenario. Here in this chapter, we will try to help Jeff in finding all the data asked by Greg. And first question asked by Greg is, he needs the name of books written by Jeffrey Archer. So now Jeff executed his first query. Select star from books. Now before we proceed, let's talk about our new SQL keyword select. So in SQL, select is used to retrieve data from our table, and the syntax is select the value from table name. Alright then, once Jeff executed the select query with a star, he got a long list of books which are written by different writers. It was again a tedious task for Jeff to get the name of all books written by Jeffrey Archer. And let's say if Jeff tried to note the list, it is very much possible that he left some of books. Alright, we talked about select keyword. Now what exactly this star Jeff had used in his query? So star is used to retrieve all the values from all the column of a table. Is this star same word like asterisk? Yes, it is same character available on your keyboard. You can find it above 8 key. In SQL, we call it star as it is more easy to say star than asterisk. Now Jeff got confused. Is there any way to get the exact value? Let's help Jeff by writing a better select statement. Let's add a where clause in Jeff select. Now the query become select star from books where author equal to Jeffrey Archer. And this query returns only those books which are written by Jeffrey Archer. So in this query, where is used as a conditional statement. Wait a second, have you noticed that the value after where clause is contained in a single quote? Yes, keep all the string values in a single quote as we have kept during inserting those values. So star shows all the columns of a table. Is there any way where we can only get the columns that we actually require? Yes, of course, you can just write the name of columns which you want to show in your result. Here in our query, we have retrieved the title and author from the book table. And in our result, we will only get the columns which we have mentioned in select. So it is better programming practice as it is also speed of your query as well as the memory used by your program. So what would happen if Greg asked for fiction novel written by Jeffrey Archer? So if we see the table, fiction novel is a category and Jeffrey Archer is an author. So these are two different columns. So we need to write two queries and then match the result. So my first query would be select star from books and where author equal to Jeffrey Archer, and my second query would be select star from books where category equal to fiction. So to overcome the issue, we can combine these two queries using AND statement. And we need to delete the complete statement of second query except the condition. So the final query would be select star from books where author equal to Jeffrey Archer and category equal to fiction. And the result would be the fiction novel written by Jeffrey Archer. In the same way, Jeff can easily answer Greg questions like all those books written by Jeffrey Archer which cost more than $19. And the query would be select book ID, title, price from books table where author equal to Jeffrey Archer and the price is greater than $19. So have you noticed that Jeff have not used any code for a teaser value? I doubt this query would return a result. It should throw an error, right? Of course not. Jeff did it correct. This query would definitely return a result. Confused? Don't worry, we have covered a topic on that in the same chapter. So let's check what all data types accept single quotes. To write valid where clause, you need to make sure that each of the data type you use are in proper format. Here's the list of data type which accept or don't accept single quotes. So integer and decimal value should not be in single quote. Rest of the others, character, varchar, datetime and block, should be in single quote. One more thing you have noticed that Jeff used a math operator within SQL query and it worked and returned the correct result. So SQL provides you a leverage of using maths operator in its statement. Let's see what all comparison operator Jeff can use in his query and get relevant result. So first operator is equal. This operator only returns those values which exactly matches with your condition. Not equal. This operator returns exactly opposite result of equal. It returns all the record that does not match your condition. The third operator is less than. This operator compares the values of column on its left with the values provided by you. It returns all the values which are less than your condition. Greater than, it is reverse of less than operator. It returns all the values which are greater than your condition and returns the row. Less than or equal to. The only difference from less than operator is it also returns all the values which are equal to your provided condition. And finally, the greater than equal to operator, it's opposite of less than. It returns all the values which are greater than your condition as well as equal to your provided condition. The comparison operator with text. Wait a second, can I use comparison operator with my text data? Yes, of course, you can use. Let's see the table. If you want all the books with title greater than T, which means all the title whose initial letter comes after T, you can use the greater than operator. And the query would be select book ID, title, price from books where title is greater than T. Now, if you see the result, it is showing only two books which with title greater than T alphabet. Alright. So one day, Greg asked Jeff to get the name of all books which are either biography or fiction. Now Jeff knows how to combine queries using AND operator. But using AND means both the condition must match to return the result. But here in Greg's case, he needs data if any of the condition matches, either fiction or biography. Jeff don't know what to do, and then for time being he decided to write two different queries. Select star from books where category equal to fiction and select star from books where category equal to biography. So to resolve this issue, Jeff need a keyword OR which combines both queries using OR statement, and you need to remove the second select statement. So the final query would be select star from books where category equal to fiction or category equal to biography. And finally, Jeff got his results using OR. Are you also confused between and OR? Okay, so we use AND whenever all condition need to be true, and OR is used for any of the condition to be true. So now Greg is asking for all customer from California. Jeff executed select star to see how he inserted the address of customer in table, and now he got confused as there are multiple customers from California, but they have different addresses. If you see the table, customer C01 Jason, who lives in San Diego, which is in California. Second customer Victor, who lives in Auckland, which is also in California. If you go deep in table, there are multiple customers who lives in different cities of California. Now the only way Jeff has is to write multiple ORs for each of the value related to California. And Jeff started writing queries. So let's start from customers where address equal to San Diego, California, or address equal to San Francisco, California, or address equal to Auckland, California. Now he got stuck as he's doing same thing as he used to do on paper, finding users one by one. So is there any better way which can help Jeff? And here is the entry of like keyword. Select star from customers where address like California. And finally, using like keyword, Jeff can get all the states value that ends with California. If you see the results, Jason, Victor, Katie lives in different cities of California, but their address ends with CA. This is why select is returning the values. Wait a minute, what is the percentage sign there before California? Okay, so this percentage is a wildcard character. Yes, that's what we call it in SQL. So we use percentage sign whenever we do not remember the value. In case of Jeff, he has multiple options in California and he needs all the option in his result. So we use percentage before California and it fetches all the values that ends with California. So if you see the query, select star from customers where address like percentage California. It may include Jamaica, Mecca, anything that ends with CA. Please note that you can also use this sign after California and it will return all the values that start with California. Same like percentage, we have another wildcard character as well. So our next wildcard character is underscore. If you see our query, select star from customers where address like underscores CA. It means it may returns all the values that ends with CA. But the catch is it only used for one unknown character. So it may results BCA, CCA. Let's say Greg asked for all the books which price comes between $15 to $30. We can use comparison operator to select ranges and the query would be select title price from books where price is greater than equal to 15 and price is less than equal to 30. So to tackle same issue, SQL also provides a keyword between which provides a easy way to select ranges. Let's write the same query of books price between 18 to 22 using between. If you see our query, select title price from books where price between 18 and 22 or 30. So it's a better way to select a range. Whenever you need to write a query to select ranges, use between. Let's recall our previous query where Greg asked for all books of biography and fiction. Now what happened if Greg asked for books from multiple writers? Let's see the query. If you have noticed, we have to add multiple ORs for each of the author. For select title from books where author equal to Jeffrey Archer or author equal to Kalam, author equal to Colino. I mean, you have to write multiple ORs for that. To handle this situation, SQL provides a keyword in. Let's see the same query using it. Select title from books where author in Jeffrey Archer, Kalam and Colino. You just need to keep everything in a small bracket and the name of authors or your conditional value in two single quotes. There is a counterpart of in keyword, not in. If you want to ignore some of the values, you can use not in keyword as well. Let's say Greg want all the books title except Jeffrey Archer and Kalam. So you can write the query, select title from books where author not in Jeffrey Archer and Kalam. It will give a result of all the authors except Jeffrey Archer and Kalam. And last but not the least, you can also use not keyword with between and like. Here are the two examples. If you see select title price from books where not price between 18 and 20, it will return a result of all the prices which are not between 18 and 22. And if you see the same with like, select title and price from books where not address like California, so it will return a result of all the addresses which are not in California. So with that, we have completed the basics of select statement. Now we'll move to the advanced level of select. Hello and welcome to session on advanced select statement. Learning objectives. In this session, we will learn the followings: how and when we can use order by keyword, use of group by keyword, different SQL functions like sum, average, count, etc., distinct keyword, and limit keyword. Let's talk about bookstore. Greg was on a vacation. When he returned to bookstore, he identified that bookstore was badly organized. Employee keep different categories books on any of the shelves where they get empty space. It was tough to find book when customer asked from a particular category. So to resolve this issue, Greg orders new bookshelves to organize books in categories, and all the books needs to be in alphabetic order. So he wrote a mail, folks, I have ordered new shelves to organize our books in categories, and these books should be in alphabetic order. So please use the below category names: biography, fiction, literature. Now Jeff, who is the manager of store, took the lead. He started analyzing the problem. So whenever a new book arrives at the store, it gets added to the books table and become the newest row in table. Now the table does not have any order. And the problem is, the boss is asking to reshelve these books. So we have more than 2000 books in store, and we need to add category sticker on each of the book and then put those books into alphabetic order. One of the staff member who has learned some queries from Jeff started writing queries. Select book ID, title, price from books where category equal to biography. For the second category, he wrote select book ID, title, price from books where category equal to literature. Alright, this can help in getting the books in categories. But what about orders in these categories? Jeff asked to that person. So to track the order, staff member has modified the query and used like keyword. So select book ID, title, price from books where title like A% and category equal to is literature, and same for alphabet B. Now this can help, but the challenge is we need to write 130 queries as there are 5 categories we have and 26 letters. So if we multiply 5 categories with 26 letters, the combination would be 130. So to mitigate the challenge of like, we need to add a keyword order by at the end of our query, and after that we can remove like keyword. So what this order by keyword does is it sorts the result in order. Now Jeff can get the list of books by his provided category in alphabetical order. If we see the results, books are in alphabetical order. Greg was happy. It was an excellent idea. Now they can easily set the book order in shelves. Now he has some other tasks for the employees. He wrote a mail to Jeff. Hi Jeff, I think we need to remove some of the old books. Can you and our staff member come on this weekend and give me the list of those books with categories and the date of purchase? Let's try to bind up by this weekend. From Greg. So to see the oldest book name, Jeff have to see from bottom of the table. So he want a way to get the list of books in reverse order. So is there any way to get the list of books in reverse order? Of course, this is where the keyword ascending and descending comes in picture. So when you climb up, it is ascending. When you are coming back, this is descending. And the query is select book ID, title, category, purchased from books, order by purchased in descending. Now it will reverse the books by purchase date in descending order. So Jeff would be easily able to get the list in reverse order, and this resolves his problem. Now let's talk about SQL functions. We have covered 6 functions which are frequently used in our day-to-day life. And these functions are sum, average, minimum, maximum, count, distinct. Let's talk about these functions one by one. Now Greg again wrote a mail to Jeff. The store is looking great. All our books are in order. Thank you for your order by clause. In past couple of months, we have great sale. I wanted to reward our staff members. They are doing great job. But for that, we need some data to conclude the rewards. So please provide me these data. Which salesperson has highest sales? Average amount per person on daily basis. Minimum and maximum sale by each person. And first, second and third highest book sales. This is the list that I want. So to answer first question of Greg, Jeff need the total sales amount of each person. And SQL facilitates user to perform mathematical operation while fetching the records. Now this can be possible using sum function. So SQL sum function totals the value of your column. If we see the query, select sum of sales amount from book underscore sales table where name equal to Jim. So here this sum function will totals the value of sales column based on condition and returns the calculated value. So the result would be the total of sales amount. So this result is only the total of Jim's sales amount because we have put a condition where name equal to Jim. Alright, so I need to execute the same query for all my salespeople. I mean, that would be a tedious task, right? Yes, that's a correct question. But my answer is absolutely not. SQL provides a way to sum the sale amount of all salesperson at once. And this can be possible using group by keyword. So let's see our query. Select name, comma, sum the value of sales from book underscore sales table, group by name and order by sum of sales in descending order. So in this query, group by will group all the first name for each of the salesperson. Sum, we already know, it will add all the values of each of the group, and order by keyword will order the columns in descending, as we have put a descending keyword over there. So if we analyze the result step by step, first thing our query would do is it would group the sales amount by each of the person, it has a separate group for John, Jim and Mary. And in second step, it has total the value of each of the person, and order by clause has arranged the results into descending order. So finally, Jeff got the result. Mary has clearly won the ground. He shared the result with Greg, but Greg had a challenge. Everyone is working hard. If we only reward Mary, others would be disappointed. That's a right concern. So can anyone help them in getting daily average sale by each of the sales executive? So to help Greg in that, we need a keyword average, which is again a function. So average function returns the average value of your column, but that column must be of numeric data type. It cannot get an average of a string column. And our query would be select name average of salesperson from books underscore sales table, and the result would be grouped by name. Now first thing this query will do is it will group the sales result by each of the person, John, Jim and Mary, and then it divides by the total number of value in that group. Let's say if we talk about John's group, then it will sum all the values of John's sales and divided by 5, because there are 5 values John's sales result. So the final result would be it's 4.28 for John, 2.48 for Jim and 5.01 for Mary. But again, if you see, the average sale of Mary is high. Now it's not fair with Jim because he was on a planned personal leave for 2 days. So why don't you find the highest sales of individuals in 1 day? Jeff suggested to Greg, and Greg agreed. So finally, Jeff executed his query using max keyword. Select name of employee, maximum sales from book underscore sales table, and the result should be grouped by name. While using functions in your queries, please remember to keep your column name into small bracket after function name. It's like a parameter passed into a function. So the result would be the maximum value of each of the person. But if we see the result, again Mary has the highest sales of 1 day. But that's a problem. Now Greg asked Jeff to check if Mary has lowest sale than any of the individual on any day. And for that, Jeff has a keyword called minimum, which is a function. So this minimum keyword returns the smallest value of selected column. And Jeff executed the query with minimum. Select name of employee, minimum sales from book underscore sales table, and the query would be grouped by name. And he got the result. But if we see the result, Mary has sold on the day which others don't have a sale at all. And this is going to be a serious concern. Can I find the sales representative who sold the book more days than anyone? So first thing Jeff needs to find is number of days they sold the books. So to find the number of days, we have a keyword called count in our bucket. It returns the number of rows which matched your condition. So Jeff executed the query, select count of sales underscore dates from books underscore sales table, and he got 13 dates count in his result. Let's see our original table. So if we see our original table, there are 13 records in it. So as per our count function, it is returning 13 records. which is absolutely a correct behavior. So what say? Will this help Jeff? Because count function returns number of record, but if we see the original table, it has same day repeated again and again. Not at all. He needs individual date of sales. He does not need the repeated value. So to remove the repeated value from the result, Jeff would require a keyword called distinct. So what distinct keyword does is, it returns the number of distinct value of a specified column. Let's write a query using distinct keyword. Select name, count, which is already we have written. We have just added a distinct keyword within the bracket with the column which we want to find the distinct value. In our case, it's sales underscore dates column. So let's see our original table, how many distinct record the sales underscore dates column has. So our sales underscore date column has only 4 records, and if we go and check the result of our query, it would also return 4 records. So this is how Jeff has got original number of sales date. Sum, average, count, nothing is working. Greg asked Jeff to find the person on second place, and Jeff already have the query and the results, so he can easily find that Jim is on second place. Alright, in our case there are only 3 employees, so we can easily find who is on second place. But if we wanted to be even more precise, we could limit the number of results to top 2 employees. And for that, SQL provides a keyword limit. Let's see how exactly limit keyword works. So limit allows user to specify exactly how many rows he want to return from the result. Let's see our query. Select name, sum of sales from book sales, group by name, order by sum of sales, and result is limited to 2. In this query, we have added limit keyword with value 2, which means we want to limit our result to first 2 rows, and the result would be